Hello, everyone, and thank you for joining us for today's webinar, Why You Should Be Using Multi-Stage Docker Builds in 2019. Today's session is brought to you by CodeFresh Live, and we'll see how you use multi-stage Docker builds and the best practices around them, even taking a Docker image from 700 megabytes down to 20 megabytes, which is a big difference in the context of CI/CD. Our presenter today is Guy Salton, Solution Architect at CodeFresh. And I just want to go over a couple housekeeping notes. You may enter your questions throughout the session, but please remember to submit them in the Q&A panel on your Zoom toolbar. So you should see a Q&A button right there on the Zoom toolbar. That just makes it way easier for us to keep track of them, and we'll address them at the end of the presentation. This session is being recorded, and a link to the recording will be sent to you later this week. Please remember to reference codefresh.io/events for upcoming webinars, as we have fresh and informative webinars for you every month. So that's it for the housekeeping items. So Guy, if you want to come on, the floor is all yours.
I'm here. Thank you very much for the introduction, Taryn. And thank you everyone for joining. So today we're going to talk about why you should use multi-stage Docker builds in 2019. My name is Guy Salton. I'm a solutions architect here in CodeFresh. And CodeFresh, if you haven't heard of it, is a container native CI/CD platform for Kubernetes. As part of my role, I give technical demonstrations and installations and workshops and help our customers on board. If you have any questions or want to ask me anything about CodeFresh, about CI/CD, you feel free to send me an email. My email address is right here. And let's start by just quickly going over the agenda for today. So we'll have a quick review of what is a Docker file and what is a Docker build. Then we'll talk about the problem with Docker build, and we'll see exactly what problem am I referring to. And the solution for that problem would be to use multi-stage Docker builds. Then we'll also talk about why you should use multi-stage Docker build specifically in CI/CD processes. We actually created some Git repositories here in GitHub with the demos and examples that I'm going to show as part of this webinar. So feel free to go and grab these repos, fork them, clone them, and go over the examples as part of the webinar, during or after, whatever you want. And so let's begin. And first slide I want to show is, and I guess that some of you might be wondering, multi-stage Docker build, that's not such a new feature for Docker, and that's true. Multi-stage was actually released in 2017, so more than 2 years ago. So why are we talking about this now? Well, apparently, companies are still adopting containers and Docker, and slowly moving into Kubernetes. And we see, and we work with a lot of customers that use Docker, and apparently a lot of them are still not aware of all the features and are not using multi-stage builds. And what you see here on the screen is actually a screenshot from Reddit just a couple months ago, where somebody posted about how to reduce your Docker image sizes and container sizes using multi-stage Docker builds. And you can see how many likes did it get, and you can see some of the reviews here. Like, people got really excited about this, and like they weren't even aware of this feature before. So we thought, okay, that's a good kind of alert and alarm for us to remind people why this is a really cool feature and how it can really help you with reducing your image sizes. So let's start with Dockerfile and a Docker build. So first, the Dockerfile is an imperative DSL that defines build commands, right? So this is a text file that contains a list of all of your commands that are needed to build a Docker image. And then a Docker build command will generate one image layer, and a complete Docker build execution will generate one Docker image. So the core principle is simple. One Docker file will generate one Docker image. And this principle works just fine for basic use cases where you just need to maybe demonstrate Docker capabilities or put some static content into a Docker image. But it can become a problem later on, and we'll see that later on. So let's look at an example of a Docker file for building and running a Go application. So as you can see, Docker files always start with a from instruction, right? As you can see here. And this from instruction sets the base image on which to run all subsequent commands. This base image can be any valid Docker image that has been custom created or pulled from public repositories like Docker Hub, for example. And then subsequent commands like copy and run, they define not only the image, what the image that's contained, but more frequently command line steps to derive your final application run state. So in this example, by using the Golang SDK image, a user may copy in their source code and then perform a build all inside the Docker file itself, right? Like you can see here. And this will result in a convenient single image. Unfortunately, the size of the resulting image frequently ends up ballooning to over 700 megabytes. So you have to pay attention to that. And especially if your application is deployed using several or more Docker images, this can be a serious problem, right? So I'm copying my source code, then I'm building my image, I'm exposing the port that the container would need to use to the outside world, and then running the binary. So let's go and see the first demo of how to run Docker build on a Go application. Of course, Docker works with any kind of programming language or technology. So it can be Java, it can be Python, or Node, but in this case, we're going to use Go. And of course, you're welcome to go and see the exact Docker file that I'm going to build in this Git repository. So first, let's go and see the Docker file. So this is the exact Docker file that you saw on the screen. And I'm going to start with the Golang image, then copy my source, run the actual Go build, expose the port, and then run the binary. So let's open our terminal, and actually the repo that I'm going to use, we can see it right here. So it already has this Docker file that I just showed you, and then the source of the application is right here, and just a single Go file, and that will output something as a web server. So we can go back to the terminal and see that we are in the root directory. Now, to build an image from our Docker file, we would have to run the Docker build command. So Docker build, then the -f to specify the Docker file. And in this case, I have multiple Docker files, and I'm going to use the first one, which is the one that we saw. Then the -t, the -t, to specify the image name that will be created, and the dot to instruct Docker that we're going to use the current directory as the working directory. So I'm going to build this image, and you see the Docker layers starting to be built. And you see that the build itself of my Go application took a while, but now I see that my image was successfully built and tagged with latest. Now, what I can do now is run Docker images and grep my image, and I see that it's here, and I can go and now run it. So to run it, I'm going to run Docker run, and then -port, -p for port, to pass the port that my application is going to communicate through, and the name of my image, which is my Go app. So I'm going to click enter, and I see that a basic web server is starting on port 8080. So now I can go to my browser and go to localhost port 8080, and I see that I see the output of my application saying I'm a Go application running inside Docker. Great. So I can now go back, to my terminal, and terminate this web server. And then I can go back to my browser and refresh. And now I see that my web server is down. So we were able to build a Docker image from a Docker file and run it, and then go and access the results. So that was for a simple Docker build for a single file. Now let's go and continue. So what was the problem with what we did now? So basically there was no problem, right? Because we got the result. But if you think about it, the image that we wanted to run, right, to run our actual web server should contain only the runtime configuration and the binary of the application itself to literally run. But the image that we got contained other things, right? It contained the whole Golang SDK image, which contains the build tools. In some other cases, it can contain some test frameworks or Git or tools that are not really necessary for running the actual web server, for running our application. And that's the problem. When you just use Docker simply like we did now, you can find yourself with a big image, as it will contain a lot of tools that are not really necessary for the actual execution, like the compilers, debuggers, build tools, test frameworks, etc. So what would be the solution to this problem? The solution could be, maybe we can generate two Docker files. So one would be a Docker file that will contain the build tools, and another one for the runtime. But the problem with this is that it will require us to first write and maintain two Docker files for the same application. And then also it will require us to write some script to manage the orchestration between the two Docker files. So maybe bash or make or YAML script. So what will be a better solution? Well, you guessed right, that would be to use Docker multistage build. So what does Docker multistage build means? It means that you can use simply one Docker file with a very simple syntax, and then this one Docker file will generate, and it will start from starting from an image that contains the compilers, contains the build tools like we used now. But then that will be for the first stage, but then it will pass only the necessary output and artifacts of this build to a second stage that will run and contain only the minimal runtime environment with the application binary for the execution of our application. So one Docker file, one build, but it will divide us to two stages. So this will help us to create multiple stages. And if that's not clear by now, we will see, of course, an example and understand the syntax and how it works. So it started from Docker 17, version 17.05. It extends the Docker file syntax to support the multi-stage build by extending two commands, the from command and the copy command. So the multi-stage build allows using multiple from commands in the same Docker file. So you see I have one from command here, but then I have another one here and here and here. And the last from command will produce the final Docker image. And all other images are intermediate images and are not the final Docker image that is produced. So the from syntax also supports the as keyword, and you can see that here. And what that means is you can then refer to some image as base, for example, right? So we're starting here from Alpine, and we tag this image as the base. And then in the copy, right, we can then refer to this by adding this as. So this image we refer to as base, this image we will refer to as second, and you can see that here from the copy, we can copy artifacts from one stage into another stage. So that's the two main extensions, so the from and the copy. And that will let us start from one image and then copy some things to another image. And then we result in a final image that maybe got copied some artifacts from other stages, but the intention is that the last final image will be small and only used for production things. So let's see a live example for that. If we go now back to our text editor, we can see an example of a multi-stage build. So what we see here is that it starts with the same Golang image as before, but now it will use this extension of the Dockerfile syntax, and it will tag this initial image as the build environment, right? Because this contains the build tools that we need for the build environment. Then I'm going to copy all my source from the directory to the container. I'm going to run the go build, right? Because I can do that as I'm still on the from this Golang app. But then I'm going to add another from command, and this will start from scratch. Scratch is the smallest possible image that you can start from, and it literally contains nothing, only what we will copy to it. So after we start from the scratch image, we can then copy things from our build environment. So the results of this Go build can then be copied into our new stage, and then we can finish by exposing our port and running the actual binary. So our last and final image start from scratch. It will not contain all the build tools. It will only contain the results of the build, like you can see here. So let's go to our terminal and we can clear the screen so it will be clear. And I see that I have my dockerfile.multistage here. I can just cut it so you can see that it's the same image that I just showed you now. Now to build this new image, clear the screen again, I can run the docker build command, then -f, then specify the name of my multistage docker build. And this image I'm going to call my Go app multistage and dot to build our new image. And you see that, first of all, this multistage image was built very, very fast, right? And I see all the logs here, and I see that it was successfully built and then tagged. And now let's see that I can run it like I was able to run the previous one. So I can run the docker run -p, then port 8080, but this one I'm going to use my new multistage app. And I see that my basic web server is now starting at my port, and I can go back to my browser and again go here and refresh, and I see that my application is running. So it worked, and I got the exact same result with the multistage build, and I can terminate this now. But the interesting thing is if I go and run Docker images and grep my Go app, if I compare the size of these two images, you see it's incredible. So the first image was 678 megabytes, while the new one that used multistage Docker build is only 5 megabytes, 0.64. And this is a huge, huge difference. So the size of the final image is much smaller, but the web server is still running. I still have what I need to run my actual application. So imagine, and we'll talk about how to use this in CI, but specifically in CI, you would want to make sure that you have the smallest images as possible, because this can also reduce the time of your CI pipelines. Now, it's important to note that, and I mentioned that before, but you can enjoy multistage with any programming language, not only Go. And we actually, in our online documentation for CodeFresh, we created some examples both for Go, but also for Java and Node and PHP. So you can click on any of these links and see how this would look like. So you see here, there's a Spring Boot 2 and Docker example, also using multi-stage builds. So here again, I will start from the initial from command that will start from a Maven with a full JDK image, and that will be used as my build tools, right, and compilers, so that this will be a large image. But then I will just copy what I need. I will run the actual Maven build, and then for my second stage, I will start from a lean, lightweight Java image that is only contain the JRE, not all the development kit tools, and then run my actual application. So again, this is the same concept with any programming language. We can look at PHP, for example, but again, same concept. So start with a large image that contains compilers, contains the build tools, whatever you need to actually build your application, then copy only what you need to the second stage. And with the second stage, you should start from a from command that starts with a much leaner and lightweight image that will contain only what the application needs to run. So that's the main concept. It's also important to note about security, and this is actually a cool thing. If you go to this Docker anti-patterns blog that we wrote, it has a lot of recommendation and best practices, do's and don'ts do's around Docker. So it talks specifically about how to create Docker images that will be lightweight, but also that will be secure. So security is also a very important thing here. And the problem is if you start using, let's say you don't care about the size, even though you should, the size of the Docker image. And if you just use a single stage Docker image and then release it to production, this image will contain all kinds of tools that are not necessary, like we said, like compilers, build tools, test frameworks, Git, but these things can also expose security vulnerabilities. So it's not only not necessary and just creates a burden on size on your production image, but it can also expose some security vulnerabilities and make your production image less secure. So it's very important that you make this distinction. And like it says here, there are 0 reasons on why a production Docker image should contain things like Git or test frameworks or compilers. They just shouldn't do that. You have to make sure that you have and create this distinction between the development images and the ones that are used for deployments. So I strongly recommend to go over this blog post and of course see all the examples for other programming languages. Now, so far we talked about the problem with Docker build and then the solution, which would be multi-stage Docker builds. Now we're going to talk a little bit about how to use these things in CI and CD. So CodeFresh, as I mentioned in the beginning, is a CI and CD platform designed for microservices and Kubernetes. So it is a container native platform. That means that every step is a Docker image. So if you look at this diagram, for example, of a classic CI/CD flow that starts maybe with a commit or a pull request, then clones your Git repository, then builds a Docker image, right, with multi-stage Docker build. You can build a Helm chart, run integration, security, performance tests, then push your Docker images to some external registry like Artifactory or GCR, ECR, Docker Hub, whatever, and finally deploy your image to Kubernetes. With CodeFresh, each of these steps will run inside a Docker image. So that will provide both isolation, but also ease of management of your pipelines, where you can just reuse those Docker images as steps in all of your pipelines. It's very intuitive and robust. The UI is very nice and friendly, but it's also fully enterprise ready. So things like RBAC, roles and permissions, You can scale to run thousands of pipelines. And finally, also contains flexible delivery, so you can work with a complete SaaS cloud-based platform, or fully on-premise behind the firewall, or with a hybrid solution. We'll see some of these examples now, but again, what we're going to focus on is actually how to use multi-stage builds in CI/CD. So let's go ahead and see our platform. Right, so this is CodeFresh, what you see here on the screen. So it's a SaaS platform. You should just go to codefresh.io and sign up for a free account. With a free account, you can run unlimited builds, by the way. So that's pretty cool. And once you sign up, it will automatically generate an account for you and show you the projects view. So this is the projects view. It will show you all of your projects, and you can then click on each project and see the pipelines for this project. So I created the project for this webinar called Docker Multistage, and this project contains multiple pipelines, 3 pipelines that I can see here. See that the pipelines are created using declarative YAML, and I can either create and build this YAML here in line, or I can pull it from my Git repository. That's also possible. And as I mentioned, each step in the pipeline will run as a Docker image. So here I have 2 steps. One of them is called main clone. The other one is called building Docker image. And this pipeline is super simple. It will first clone my Git repository. And this is the same repository that we used so far with our Docker files. So it's this one, right? So I just remind you that we have the source of our Go application here. And we talked about 2 Docker files so far. There's the first one simply called Docker file. And this one is using a single stage, right? So only one from statement that will contain both the build tools, compilers, and eventually the application runtime and binary. And the other one, which is called dockerfile.multistage. And this one is a multistage Docker file, which has 2 from statements. The first one that will start from a bigger image that will contain my build tools, my compilers, etc. And the second one will contain only the runtime configuration and binaries to run my application. So these are the 2 Docker files, and this is my repository. And what I'm going to do here is first clone this repository. And to clone a repository in CodeFresh, it's very simple. You just have to set the type of the step as git clone. Okay, and you can see, by the way, all of the steps here. So if you just search for clone, you see that you can use this interface to easily add steps into your pipeline. You can actually use a form for that and just provide the working directory for your projects, the name of your repo, the revision, and the credentials. So I'm going to choose this repository, and I'm going to, as the revision, use this CF_branch. And I create a trigger for this. So every time I make some commit, some changes in my repo, it will send the webhook to CodeFresh. CodeFresh will parse the JSON payload that comes from the webhook and then populate this variable with the branch that was changed. Once this clone step is executed, CodeFresh will clone my code. It will place it on a volume. So each pipeline gets a persistent volume, and then I can then access any of my project files in any subsequent steps. That's what I'm going to do here. So the next step, I'm going to access my project files, specifically the Docker file, and run a Docker build. So to build a Docker image as part of CodeFresh, I don't need to run Docker build commands like I did earlier in the terminal. I can just set the type of the step as build, point to the Docker file that I would like to build, and finally provide a name for my Docker image. So here I just called it my Go app image. and I can run it. So I actually ran it already. And if I go here to builds, I can see that this is the execution of my pipeline. I see that it took 1 minute and 31 seconds to run the whole thing. So only 5 seconds to clone my Git repository with the master branch, and then another minute to build the actual Docker file. And I see all of the Docker file, the Docker build logs here. So I see, right, it started with the Golang image, and then it copied the source, it ran the build, exposed the port, and that's it, right? And so this is how I ran a CI pipeline that built my single stage Docker file. Then if I go back, I see that I created another pipeline, and this one is very similar to the first one. So it also contains 2 steps, the clone and the build. The clone step is exactly the same, as it's going to clone the same repository, but the build one is different, as this time is going to point to a different Docker file, and that's the multistage Docker file in my Git repository. And also the name of this image is different, as I wanted to differentiate these 2 images. So this one I called my Go app multistage image. And we can go to the builds, and I ran this one as well just before the webinar. And I can see that here, the build of my Docker image took only 40 seconds. And if I look at the logs, I can see that I have the 2 from statements here, right? So it starts with my Golang app, copy the source, then run the Go build, but then it starts from scratch, copies from the first stage only the necessary binaries, and then creates my final image. So now I can go and see, and inside of CodeFresh, we have an internal Docker registry. So once I built my image, it pushed it automatically to my Docker registry. And I can go here and search for my images. So I actually built 2 images, right? And that was the my Go app multistage image and the my Go app image. So I can go and see both of them. And like we saw locally, we see the same thing here. The my Go app image weighs 646 megabytes, while the my Go app multistage image weighs only 5.37 megabytes. And I can click on each of them and see here we show the complete view for the Docker image itself. So I can see when it was created, who created it, if it was promoted to any other registry. I can go and promote this image to any external registry that I have connected to my Docker, to my CodeFresh account, like to ECR or to Docker Hub. I can add a tag, and I can go and see the actual layers of the Docker image. And that's really interesting because we can see the difference between the 2. See that here I have a lot of layers, and you can see the size of each layer, right? And that's what results eventually in my final image that is almost 700 megabytes in this case. I can click on the logs and see the pipeline that built this image. How long did it take it to run? When did it run? I can see the Docker file itself, right? And this is our single stage Docker file. And another cool thing that I can see is the code to cloud traceability. So from this image that was built, I can see trace back all the way to the latest commit in my Git repository, and then understand what change triggered the pipeline that eventually built this image. So this was for the first image, and I can go back and then let's compare it to the multistage image. So if we look at the multistage image, again, we see the activity here, but if we click on the layers, see the difference here. So Everything that you see as labels, this is just kind of tags. You can add any metadata labels to a Docker image, and then we use it internally in CodeFresh for filtering, right? So in the images view, we can filter according to the repository name or to the owner, etc. So these are just labels. You can ignore them for this. So the actual layers for my image are only 3 layers, right? And you see that the size is so small. So you see visually the difference between the 2 images, the single stage and the multi-stage. We see, of course, that this is the multi-stage with the 2 from commands. So this is extremely useful for CI. Imagine that now, for every commit or every change of each of your developers, you want to trigger a CI or CD pipeline, and this CI pipeline will need to build an image from the Docker file that you have in your Git repository, then run some tests, then deploy this image. Then if you use multi-stage Docker builds and you design your Docker files as multi-stage, you can significantly reduce the size of the images, and by that reduce significantly the time of your CI and CD. And that's, if you think about it, the time to release. So how much time would it take from the moment that a developer pushed a change until this change is ready in production? This is very, very important. And again, I want to emphasize the importance in the security perspective as well. So if I use here the single stage, that means that if I now go and deploy this image to my production environment, to my production cluster, it means that an image in my production cluster is running, and this image contains a lot of things that shouldn't be there and are not necessary in production. Things like compilers and build tools and test frameworks and Git. And I just don't need these things. They weigh and they take a lot of space and time, but they can also expose my image and application to security issues. So that's another very important thing. Now, you saw that CodeFresh supports multi-stage Docker builds as a native support, right? You don't have to tell CodeFresh anything. You just point to the Docker file that you have. It can be a multi-stage Docker file or not. The last thing I want to show you here is that, and this is not a very popular use case, but you can see sometimes that users are using it, is that we said that generally with multi-stage Docker builds, we have multiple from statements, right? And we said that the final from statement is what creates the final image. But that's not always the case. So sometimes, and we can actually go back to the application and we can look at this example again. So let's say that here I started from with some base image, then I added some steps, I added some things to it. I started with a second from statement, and I added some text, then a third, then a fourth. So by default, this will be the final image. But what if I want to use this image, the third one? So Docker added support for that, and this is support is used by something called target. So you can add a target to your Docker build command, specifying the exact target of what final image you want to end up with. So by default, it would be with the final from statement, but you can choose whatever target you want. And why would you want to do that? Because maybe you started with some image that contains some test frameworks, right? And you don't want to use this image in production, but you might need to use this image to run some tests before you go and create the final production image. So let's see how you would do that in CodeFresh. So here in this example, I'm cloning the same repository, but I'm actually pointing in the build step, I'm pointing to a third Docker file, right? Called dockerfile.multi example, not multi-stage. and we can go back to our application and see this Docker file. So this is the one that I actually showed you on the presentation. It will start from Alpine, it will tag it as base, then it will go and add CURL tool to this stage. Then the second stage will start from Debian. This will be tagged as second, and it will print hello to some folder here. Then the third image will start from Ubuntu. And lastly, the final image will copy things from the other images. And it will also try to run CURL and see that it has access to it as it starts from base here. So I can go and see that I can add a target parameter and then choose what would be my target. And the target you can refer to simply by the label that you give here. So here I see that I have a label with image that is second, this one is third. So let's say I have this Docker file and I want to end up with the second one, right? So all I have to do is add a parameter called target and then set the value as second. And if I go to the build of this image, I see that it ran successfully. I can go to the logs of the Docker build. And let's see what's happening here. So I see that it started from Alpine 3.5 as base, 4.5 as base, right? Then it ran apk add CURL. Then it had the second from statement, which is Debian as second, right? It copied the file, and that's it. Now you see that it's just adding some labels. So image second, and it's not going and continuing to the third. You see, I don't see the third from statement here. That's because I set the target as second, right? So that will be my final image. If I would go and run a Docker build on the same exact Docker file, but remove this target parameter, right? It will go and continue to the third image and then to the final image. So this is just for you to know that you have the support for this target parameter. So that's what I want to show you here. And you know what, we can see it also on the images view. So let's add another image, and that would be my, this would be multi-example. Where's that? No, let's cancel this. Maybe this one. Now we can go and see how we call this image. So go back to my project, to my pipeline, and this image I called multi-stage example, right? So I can go back to images. And I can go look for example. So multi-stage example, I can click on it, and this one is 108 megabytes, and it has the tag of second target. And if I go and look at the layers here, I see that it has this tag of image equals second, and it ran the layer of echo hello to hello, but it doesn't contain the rest of the subsequent layers, as I stopped only after the second. So that's the Docker file for it. Great. So we can go back to the presentation. This we already talked about. And then just summarize. So we saw that by using one Docker image for both the build and production, this will result in slow deployment and lots of CVE violations. So that's in terms of security. But also with slow deployment, and that's because the images can be very, very big. Multi-stage build can produce then a lean, more secure, and production-ready Docker images because it will not contain any unnecessary tools like test frameworks and build tools and compilers and Git and stuff like that. And in terms of CI with CodeFresh, you can have speedier builds thanks to caching, as we provide Docker cache by default, but also caching on the intermediate Docker layers. So even if you make some changes at the end of your Docker file, we will still, so we will pull all the existing layers from the cache and only build the new ones. So that's it, and thank you very much.
Thank you so much, Guy. So at this time, we'll go ahead and go to our Q&A. Just a reminder, if you have any questions for Guy, please enter them in the chat or in the using the Q&A button on your Zoom toolbar. For our first question, I have, thanks for the great webinar. Do you have any experience or advice on how to properly organize a multi-tenant pipeline for auto-scaling SaaS using CodeFresh service, Kubernetes, etc.?
So definitely, I suggest that you can give me, just send me an email to my email address, and we can talk about this after the webinar and, you know, discuss your specific use cases and what exactly do you need to do. But with CodeFresh, definitely, especially if you're using containers, if you are deploying to Kubernetes, we have all the capabilities of building your pipelines for scale for your applications. So we can definitely discuss this after.
Sounds good. And let's see, is there a possibility to run similar CodeFresh environments on premise?
Yes, you can. So we actually have 3 offerings with CodeFresh. 3 installation options, and the first one would be the cloud version, and that means that it's completely SaaS, cloud-based, and it means that you sign up to the SaaS platform, but then once you create your pipelines and you run them, they will be executed on some cloud-based environment. That's the cloud version. There is another option called hybrid installation, and that means that you still sign up to the SaaS platform, but you can install an agent on your own Kubernetes cluster that can be behind the firewall on your own environment. And then most of the application is still hosted in the cloud, but your actual builds will run on your own infrastructure on this agent. And then if you need to access any internal assets, like let's say you have an on-premise Git repository or behind the firewall Git repository, or you need to access any internal Docker registry that is behind the firewall, or deploy to an on-premise Kubernetes cluster, then you'll be able to do all of these things seamlessly because this agent can be on the same network as your own internal assets. So that's the hybrid installation, which I strongly recommend. And there's also a full on-premise installation. So that means that you can install the whole CodeFresh application, including the UI and all our services, on your own environment, and it can be completely disconnected from the internet. So all of these are possible.
Thank you very much, Guy. So I've launched a poll. If you all would give us your feedback, we really appreciate it on how this webinar met your expectations, or if it did rather. So thank you all for attending so much. Keep an eye on codefresh.io/events or any of our social channels, and we'll be announcing our upcoming webinars. We actually just got one on the schedule for a new feature called debugging. Guy, I don't know if you can just say a line or two about our upcoming debugging webinar.
Yes, for sure. So CodeFresh would be, I think, the first platform, CI/CD platform that introduces the debugger, and this is super useful if you ask me for creating your scripts, because like with any IDE for developing your code for your application or scripts, now also with your CI/CD pipelines, you could run them in debug mode, and then use this to pinpoint the issues, understand the values of each of your variables at each stage of the pipeline, and then, much easier troubleshooting and understanding what's wrong to fix your pipeline. So it's going to be really cool and interesting webinar.
Yes, and that one is going to come up on November 13th. So keep an eye out for that. Follow us on our social channels and check out codefresh.io/events. And of course, sign up for a CodeFresh account if you haven't done so already with free unlimited builds. So thank you so much, Guy, and thank you everybody for attending today. We hope to see you next time. Have a great rest of your day.